Hello dear Prep 1 students, today we will start lesson 2 in unit 2. In this lesson we will talk about the magnet. Let's start. At first I will ask you a question. Do you know what is the idea of making magnet? The idea to make magnet come from what? Come from a natural stone called lodestone. This is a stone discovered in Magnesia in Greece, okay? Some people observed that this stone attract certain material, okay? Then discovered the structure of this rock or stone and make a magnet like it, okay? So the idea of making artificial magnet is what is lodestone. It's a natural rock found in the nature, discovered in Magnesia in Greece, okay? So the natural magnet called lodestone. Natural magnet called lodestone. And we have artificial magnet that we made it, okay? The natural magnet is characterized by its ability to attract certain material. We said before, some material attracted to magnet like iron, cobalt, nickel, steel, okay? And the production of industrial magnet began in 19th century, okay? And do you know before also the magnet has two ends or two poles known as South Pole and North Pole, okay? South Pole, it's colored by blue color and symbolized by letter S. And the other pole called North Pole, colored with a red color and symbolized by letter N, okay? So any magnet has two poles, North Pole and South Pole. And the artificial magnet has a different shapes like number 1, pearl magnet like this, number 1. Number 2, horseshoe magnet or U-shaped. Number 3, magnetic needle. Number 4, magnetic ring. Okay, so the artificial magnet has different shape or vary shape like needle, a ring, horseshoe and pearl magnet. And as we said, natural magnet called lodestone. Okay, look at this. What happened when we separate the magnet into different pieces or many pieces? We separate it from South Pole. What happened? The separated part will have two poles also, okay? Not one pole only, two poles, North Pole and South Pole. So each separated part has two poles like any magnet, okay? That mean what? That mean it's impossible to get magnet has one pole only, okay? Look at this. When a single magnet is divided into several parts, each part of them form a new magnet with two poles, one of them North Pole and the other South Pole. That mean what? It's impossible to obtain single magnetic pole. Okay? Now we will divide the metallic material into some of them attracted to magnet and the other not attracted to magnet. The material attracted to magnet that's called magnetic material. Okay? Magnetic materials, they are materials that attracted to the magnet. Like what? Iron, cobalt, nickel, steel. Okay? And the non-magnetic material, they are materials that not attracted to the magnet, like silver, gold, aluminum, and copper. All of them metals, but some of them attracted to magnet and the other not attract. So they called non-magnetic material. Okay? Look at this. What happened? When a magnet is brought close to a mixture of copper filling and iron filling and sand. What happened? As we said, copper is metal but not attracted to magnet, non-magnetic material. But iron attracted to magnet is a magnetic material, okay? So only iron fillings are attracted to the magnet, okay? Life application. We use the magnet in criminal investigation, okay? We use it in criminal investigation to see the unclear fingerprint, okay? There's a crime, we use the iron filling and magnetic brush to see unclear fingerprint on the surface, okay? The steps, firstly, a magnetic brush is brought close to the iron filling which are attracted to it. Okay, firstly, the magnetic brush, this is called the magnetic brush, will attract iron filling to it. Then we will take the brush and pass over the surface where unclear fingerprint are present. On any surface has an unclear fingerprint. Okay, what happened now? Some iron filling will stick to the traces left by fingerprint, stick to lines of fingerprint, which make it what? Visible, make it clear. So we use a iron filling and magnetic brush to see the unclear fingerprint in any crime. Okay, now we will talk about the properties of magnet. Number one, we said the attraction force of magnet concentrated in what? Concentrated at poles, not middle. When you put a magnet in iron filling, the iron filling will collect it at the poles, okay? Not collected in middle. That mean what? That mean the attraction force of a magnet is strongest at its poles, and its decrease as it gets closer to the middle. Okay, so the first property of magnet, the attraction force of magnet strongest at poles and decreases when you get closer to the middle. Okay, look at this question. What happened when a bar is a magnet dipped into the iron filling? What happened? The iron filling will attract it to the magnet, which highest density, highest concentrated at what? At poles. Highest density of filling at the poles of magnet. And the density of filling will decrease at the middle of the magnet, okay? So the iron filling will collected at poles of the magnet, okay? Look at this, collected at the poles, but in the middle there is no iron filling, or their density will decrease. Okay, density that mean amount. Okay, so if ask you, give reason the iron filling collected or has a more density at poles, because what? Because the attraction force of magnet is strongest at poles and the decrease when get closer to what? To the middle of the magnet. Okay, the second property of the magnet is a magnet always take a certain direction when it's suspended freely. And the second property is a magnet always take a certain direction when it's suspended freely. Look at this. When suspend the magnet freely on a thread, the magnet has two poles, as we said, north pole and south pole. Okay, always the north pole of magnet pointed to what? Pointed to geographical north pole of the earth. Geographical north pole of the earth. But the south pole of magnet, the suspended freely, always pointed to the geographical south pole of the earth. Okay, so when we suspend the magnet freely, always take a certain direction. North pole of magnet always pointed to geographical north pole of the earth, but south pole of the magnet always pointed to geographical south pole of the earth. Okay, and the earth act as a giant magnet. Why? How act as a giant magnet? Look at this. Inside the earth there is a layer called core. This layer consists of iron, cobalt and nickel. Okay, so it acts as a magnet. Okay, so the earth act as a giant magnet, has طبعا to north pole and south pole. The north pole of the earth attracted to geographical south pole. North pole of the earth attracted to geographical south pole, but south pole of earth is what? Is geographical north pole of the earth. So when we suspend the magnet freely, north pole attracted to geographical north pole, because the magnet of earth is what? Is south, and we said different poles will attract. Okay, so the magnet, north pole of the magnet suspended freely, attracted to what of the earth? Attracted to south pole of the earth. Okay, it's a different pole. and pointed to geographical north pole of Earth. Okay? But the south pole of the magnet suspended freely pointed to what? Pointed to south pole of the Earth, geographical south pole, and that mean what? Attracted to north pole of Earth. The magnet inside the Earth will be opposite. South pole of magnet we have suspended freely, attracted to what? The opposite pole of the Earth. Okay? Look at this. The magnetic south pole of the Earth is what? A geographical north pole of the Earth. Okay? A south pole of Earth, geographical north pole. But the magnetic north pole of Earth is what? A geographical south pole. Okay? So the magnet opposite to the geographical poles. Okay? And when a magnet suspended freely, it always take a certain direction. Okay? Where? We said the north pole of magnet suspended freely pointed to what? The geographical north pole. And the south pole of the magnet that suspended freely always pointed to geographical south pole. Okay? That mean what? That mean north pole of magnet suspended freely pointed to geographical north pole. That mean attracted to the south pole of Earth. Okay? Attracted to south pole of Earth. And the south pole of magnet suspended freely pointed to geographical south pole of the Earth. That mean attracted to north pole of the magnet inside the Earth. Okay? As we said, Earth acts as a magnet. Okay? Has two poles, north and south. Life application on the use of magnet to determine the direction. It is this tool, the compass. Okay? The compass is a tool used in the past to determine the four direction of the Earth: north, south, east, and west. Okay? This tool made of what? Made of a free magnetic needle fixed on its pivot. Okay? Pivot to make it turn. Okay? Needle fixed on its pivot. So the compass made of what? Free moving magnetic needle fixed at its pivot. And has put it in the box. This box made of what? Made of copper or plastic. Why made of copper or plastic? To prevent the attraction between the magnetic needle and box. To not attract to each other, and that affect the directions. Okay? Which can affect its movement. So the box made of what? Copper or plastic, non-magnetic material, to not attract to magnetic needle. And its importance as what? The compass is an old tool used to determine the Earth's four main geographical direction: north, south, east, and west. Okay? Look at these questions. Choose the correct answer. When a paramagnet divide into two magnet or two parts, we said when divide a magnet, we will get new magnet has two poles also. So we will choose B. Okay? Number 2, in opposite figure, when a pole placed between two magnets, the magnet are attracted to the pole. Okay? Will attract the pole. That means what? Pole made of magnetic material. And we have a nickel only. It's a magnetic material. Number 3, the geographical direction which a freely suspended bar magnet take. We said always take a certain direction, north and south. Number 4, the Earth acted giant magnet affected the direction of magnetic needle of a compass. It directs the north pole of the compass needle to point toward what? As we said, to the magnetic south pole of the Earth. We said the compass or suspended magnet will point to a north geographical pole, but the magnet inside the Earth will be what? Will be south. Okay? Compass north will attract it to south pole of the Earth, but geographical north pole of Earth. Okay? Talk about the law of attraction and repulsion. As we know before, the same balls repel each other, but different balls attract each other. Okay? Look at this. What happens when two different poles of magnet are brought together? What happens? The poles of the two magnets attract each other. Okay? As we said, the different poles attract each other. But look at this. If we have two magnets, the poles of them south. Two poles close together, same poles, south. Okay? The poles will what? Will repel each other because they are same poles. And it also has same poles, north to north. So the poles will repel each other. So what is the law of attraction and repulsion? Is what like or similar magnetic poles repel each other, but unlike magnetic poles attract each other. That's called law of attraction and repulsion. Okay? Look at this figure. Look at this. The opposite figure shows 4 ring magnets placed on a vertical route. If the lower magnetic pole of the magnet A in the lower is north pole, conclude the type of poles 1 and 2. Ask about 1 and 2, poles of 1 and 2. We said magnet A, lower part of it is what? Is north. Is north, okay. North pole. And we said any magnet have 2 poles. So the upper part of this magnet will be what? Will be south. Okay? And there is repulsion between magnet A and magnet B. That means what? The lower part of magnet B is south also. As we said, the same poles repel each other. And the other part of magnet B will be north pole. And there's attraction between C and B, magnet C and B. That means what? That means the lower part of magnet C is south. Different poles, okay? And the upper part will be north. And there's a repulsion between magnet C and D. That means lower part of magnet D is what? Is same of upper part of magnet C, right? So it will be north and the other will be south. Okay? So the pole of B, lower pole, will be what? Will be south. And the lower part of magnet D will be north. Okay? So the pole of B, lower pole, will be what? Will be south. And the lower part of magnet D will be north. Okay? We'll talk about the magnetic field. Around any magnet, there is a region of space in which the effect of magnet appear. Okay? In which it will attract any magnetic material. Area around the magnet. This is area called what? Called magnetic field. Okay? So the magnetic field, it's a region of space around the magnet in which the effect of magnet appear. Magnetic force appear. It will attract any magnetic material that put on this area, okay, or that found in this area. Okay, so can attract any material from a distance, but must be in the magnetic field. Okay, and this magnetic field represented by line. Okay. And this line, imaginary line, not found in real, that's called magnetic field lines. They are imaginary line that represent the force of magnetic field. Okay, so around any magnet there is an area called magnetic field and represented by magnetic field line. Look at these figures. If we have 2 magnets, north pole and south pole, close together, what can you observe? The magnetic field transfer from north pole to the South Pole, or start from North Pole to the South Pole, okay? And look at this. If we have one magnet only, what can you observe? The magnetic field denser at what? At poles. At poles. Look at this. The line of magnetic field increase at poles, but separated at middle, when we move away from the poles, okay? And if we have same poles, north and north, what can you observe? The line repel each other, okay? There is a repulsion force between them. So the line repel each other and not intersect each other, okay? So what is the properties of magnetic field line? Number one, they are imaginary line and that not intersect each other. Number two, they start from what? As we said, from North Pole and end in South Pole, okay? Number three, they are denser near to poles. The line are denser or increase at what? At poles. And far separated as they move away from the poles, okay? Separated. The opposite figure shows a serial magnet placed on a hand and yet attract paper clips to it. Number one, what is the material which the paper clips are likely made? Paper clips attracted to magnet, so they are made of what? Iron, cobalt, nickel, steel, magnetic material, okay? So the first answer, any magnetic material that is attracted to the magnet, such as nickel or iron or cobalt or steel. Number two, what do you conclude from the attraction of paper clips to the magnet even though a hand is between them? That mean what? That mean paper clips are found in the magnetic field. Magnetic field of magnet extend through our hand and attract paper clips, okay? So that mean magnet, there is a magnet and paper clips found in their magnetic field, okay? Or in its magnetic field. So attracted to it. So what is the answer? The magnet has a magnetic field that extends through the hand and attracts the paper clips at a distance by magnetic force, okay? Without contact. Okay, if we have two magnets, there is repulsion may occur or attraction. Repulsion if two poles close to each other, same poles, and attraction will occur when we close different poles to each other, okay? But when you put a magnetic material close to the magnet, attraction force only occur. There is no repulsion, okay? If it's magnetic material found in magnetic field, it will attract it only. There is no repulsion. Look at the note. The force between any two magnets can either be an attraction force or repulsion force, while a force between a magnet and the magnetic material in its field is always an attractive force, okay? Look at the questions. Number one, the opposite figure represents two magnets placed on a pencil. Which of the following are symbol of the poles for two magnets? We will look at the choices. Number one north and four south. Let's try it. One north, so the other pole will be south, and there is repulsion between 2 and 3, so 3 will south also, and the 4 will north. So this is choice false. It said 1 north and 4 south. It's false. Number 2. 2 is south and 3 is north. Look at this. 2 and 3, there is repulsion between them. So they have the same pole. Okay? So it's wrong. Number C. 1 in and 3 south. Look at this. If we will put 1 in, so 2 will be south, and there is repulsion between 2 and 3, so 3 will be south also. So it's a true choice. Okay. Number 2, the opposite figure show the direction of a compass needle when placed near to the pole B of a magnet. Which of the following identify the magnetic poles B and D? Look at this. North pole will attract to what? Attracted to opposite. So B will be south. Any magnet has two poles, so the other side will be north. And there's attraction between A and C, so this C is opposite, so will be south, and D will be north. Okay, so B south and D north. B south and D north. Letter A. Okay. Number 3. The opposite figure represents the magnetic field line between two magnetic poles at which point the magnetic field strength is greatest. We said the magnetic field strength increase at what? At poles. Okay. So we will choose point B. Look at this. It's a close to poles. B. Number 4. Which of the following represents the correctly magnetic field lines? We said magnetic field starts from North Pole and end in South Pole. So we will choose number B. Look at this. Start from north to south. And the arrow of north go out. Okay. But the arrow of south go to in. Okay. So you will look at the direction of arrows, like electric field lines. Give reason. The density of iron filling increase at poles of magnet, as we said, because what? The attraction force of magnet is strongest at poles and become or decrease at middle. Okay. Number 2, electric field lines are magnetic field lines, and magnetic field lines are similar in some properties. As we said, they are similar in what? The both are imaginary line and not intersect each other. Okay.